So how do we go from the idea of a cell phone and get a cell phone and then sell the cell phone, right? It involves people who know mathematics, people who know science and technology, and people who know business, right? Think about Samsung and Apple. These tools would not be where they are if we didn't have business and management people. Well, my name is Amos, the math guy, and I love math, I love science, but I've learned through the years that I also need business people and people that understand management. And so I have two of my friends that will be joining me as I teach and encourage students, the future generation of scientists, mathematicians, and engineers. And so they would introduce themselves, and you guys will be seeing a series of videos that cover topics in aviation and computer science and so on and so forth. So I'll let them introduce themselves, and then we'll talk a little bit about our NASA expedition in Houston. But let me allow Dr. Colin Gan to go, and then we'll talk to Nixon.
Okay. Hi. Yeah, like he said, my name is Dr. Colin Gan. I'm from Singapore. I'm excited to be here to share my expertise and ideas on innovation. I'll be teaching a class on what is the theory of innovation, what is the philosophy of innovation, and how innovation started, and hopefully get the students involved in a project involving innovation over a timeline of 1 to 2 years. Eventually, we hope that they can file a patent out of it. Yeah, thank you.
Thank you, Dr. Colin.
Yeah, thank you, Amos and Colin. My name is Nixon. I'm a PhD student in computer science. I love AI, I love coding and programming, and I'm excited to share my experience with the kids, and with everyone else. So in this few weeks, I want us to look together at unsupervised learning, supervised learning, what we can use AI to. Did you know, Amos, that AI can be used as a tool for arts?
For arts?
Yeah,
no.
Sure, it can. So so we're going to look at how we do that. We're going to look at some useful programming languages that we can use for that, like Python. There are so many libraries in Python that will help us achieve that. For example, the NumPy library, and we've got Keras and so many interesting libraries that we can work with.
Wow, so I have a few quick questions just to help our co-instructors to share their passion too. So Nixon, you're saying when the students want to start computer science as part of learning how to be innovators, what languages are we exploring at the beginning?
Also at the beginning, I think it's going to be interesting and fun for students to start from scratch. Yeah,
okay.
And by scratch, I mean like the Scratch software is a tool that was designed by MIT.
MIT, okay.
Yeah, it's very interactive and very fun to learn, just to give the students the basic idea of what programming is, how to develop algorithms and all of that. And from there, we can move to Python, just the introductory part of Python. And we'll move to Teachable Machine Learning by Google Cloud.
Okay, wow, excellent. And Dr. Colin, you studied computer science in your undergraduate. What inspired you to do that?
Yeah, what inspired me is I wanted to be building interesting software like cloud computing, supercomputing software. That's what I got interested in, and I did some of my graduate studies on that.
Okay. And then your master's was computer science too. Yes. Was there a certain field you focused on for that part of your master's?
Oh, I specialize in control engineering actually.
Okay.
So I built something using fuzzy logic controller.
Okay.
Yeah,
Wow.
That was many years ago.
Yeah, and then you did another master's in management.
Yes. Yeah, I did that because I think, as a computer scientist, if you do not know anything about management, it's difficult to start a business.
Okay.
Yeah.
And then your PhD work, sir?
Yes, my PhD work was in finance. I finally did a PhD in finance from Bandung Institute of Technology, specializing in risk management of investment portfolio. Yeah.
Wow. And Dr. Colin studied in England, Australia, America, Singapore, and Indonesia. Wow. Now, here's an interesting fact. Nixon and I were actually from the same state in Nigeria. So that was pretty cool to see that he was born in Garkida, which is in northeastern Nigeria. So we have some plans, hopefully, that would help the youth in Nigeria and Indonesia and around the world. Our programs are open to people from all, wherever you're from. We want to inspire the next generation of scientists, mathematicians, and thinkers who also know the history and philosophy of science. I love talking about the history of math, history of science, because it's good to know the context, right? There's one last thing I want to address, which is supercomputing and quantum computing, and just some of the things we want to sort of get kids thinking about. But before we do that, I want to just give one word of encouragement to educators, and that is that we need to start teaching math together with computer science, together with chemistry and physics and engineering, combined, like we need to try and have opportunities for an integrated learning approach. Because there's no sense in telling someone to learn a principle in math without showing them where it connects in the grand scheme of things. So we want to do more project-based learning. We want kids to learn how to program from a very young age. We're building a computer science curriculum, or at least a platform that takes you from learning your Word, PowerPoint, Excel, graduating HTML, CSS, JavaScript, and then Python, and so on. I think this is the new normal we need to have. So what is the next frontier? What do you guys think in computer science and so on? What should kids be looking forward to?
Oh, a lot. AI is a disruptive technology. I mean, it's changing the way we approach business, we approach commerce, we approach even politics.
Wow.
For that matter. I mean, yeah, you can have models, modeling a lot of things from diverse fields. And right now, I think we should be looking at quantum computing, because it's going to change like a lot of the way we do things in the computer science field.
Wow. Colin, supercomputing, what about that? How does this fit in?
Yeah, supercomputing, yes. I think people are already using that, especially people doing AI. They are running their algorithms on NVIDIA computers. Those are supercomputers.
Wow.
And even the founder of NVIDIA, Mr. Jensen Huang himself said that he designed his own NVIDIA supercomputer using artificial intelligence.
Wow.
Yeah. And to train our artificial intelligence models, Mr. Collins, we also need supercomputers, powerful computers, and we'll be teaching these kids how to do that on platforms like Amazon Cloud Services, AWS,
Yep.
so that they can, the training of those models can be fast and accurate.
Wow. And you guys were talking about, as far as the technical piece, that for those who love computers, where you said we had the ones and zeros, and now we're going to try and put things in between.
Yeah. That's the concept of quantum computing,
Wow.
So we have a lot of challenges when it comes to discrete, representation in the form of zeros and one. It's either right now 0 or 1. So yeah, the concept of quantum computing is saying we can have representation in between 0 and 1, and that's crazy, right?
Wow. Wow, this is a great time to be alive, and I think that we need to help kids to know what they want to do with their lives younger. I don't think it's an advantage to leave kids all the way to 12th grade without direction. I think we need to give them direction, and then they can always pivot later. But that's one of the things we hope to inspire, is help kids have direction earlier on. So I'm excited to go through this journey and present opportunities for students around the world to engage with technology, to see how it connects to their vision for life. Let us know if you have any questions. Our emails will be on the website. Have a blessed day.
See you.